Hi, hello dear students, welcome to Karnataka Sslc classes. So in the previous videos we have studied about the arithmetic progression of the part 1. Okay, so in the today's class we will study about the second chapter called triangles. Okay, so exam point of view this chapter is very important. Okay, so try to learn from the basics, okay, and get good marks. Okay, fine. So we'll start with the triangles chapter 2. Yes, see, so in the triangles first we need to understand what are called similar figures. See, in our day-to-day life we see different objects, okay, and objects resemble to some other objects. Okay, it means we compare one object with the other object, isn't it? For example, you are going to say that like if you take a mountain, it is a mountain, isn't it? So it is a mountain. So mountain resembles, okay, what is the shape of this mountain? So the shape of this mountain is triangle. It is a triangle. Okay, now if you see a moon, okay, if you see moon, so again you can resemble or you can compare the shape of this moon to what? Circle, to circle. Okay, so there are different objects, so we compare different objects with the other figures. Okay, so what we can say is in similar figures the shape is going to be same. Okay, the shape is going to be same, but the size may or may not be same. Okay, what I mean to say, suppose if I make use of triangles, let me take triangles. Okay, so if this is an equilateral triangle, this is an equilateral triangle, okay, all sides are equal, okay, and with each side a, okay, and if I make use of one more equilateral triangle of each side 2a, of each side 2a. Now you can see both figures have a same shape, but the size is different. What do you mean by size? Size means the sides. So each side is a but here each side is a 2a. Okay, so such figures where the figures have the same shape are called to be similar figures. Okay, now these similar figures you can apply to even other kind of figures as well. I mean to say you can use this similar figure principle to even circles, okay, circles, okay, triangles, okay, square, okay, rectangle. Okay, so two other figures also you can use. It means in general you can say you can even apply for polygons also. So the closed figure which has a minimum 3 sides, okay, I mean it starts with a triangle, then 4-sided figure, 5-sided figure, 6-sided figure, and it is called to be polygons. Okay, so the concept or principle of similarity is applicable for different types of shapes. Okay, fine. So how you define similar figures? Similar figures, okay, similar figures we can define, okay, the figures that have same shape. Okay, they should have a same shape, and okay, they may or may not, okay, may not have a same size. Okay, so when I say two figures are similar, they have a same shape but size may be equal or may not be equal. Okay, such figures are called to be similar figures, and similar figures is applicable for all types of other figures like circles, triangles, I mean quadrilaterals, pentagon, hexagon. Okay, so one example I will show you. So if you are making use of a circle, okay, so if you can see these are actually concentric circles. Okay, these are nothing but concentric circles. All the circles have a same center, but they have a different radii. If it is r1, okay, second is r2, okay, third is r3. Okay, so they have different radii, but however the shape remains the same. What is the shape? Shape is circle. Okay, now one more example. So I'll take a square. Okay, in square, you know, all sides are equal, all sides are equal. Okay, now I'll take one more square from the first square. See what I'll do, suppose if it is 2 centimeter, each side is 2 centimeter. Okay, I'll add equal length to all its sides. It means I'll add 3 to all sides, so I will get 5 centimeter. Okay, all sides becomes 5 centimeter. Again it is an square with the 5 centimeter, and you can observe that the corresponding angles are going to be same. It means 90 degree. All the corresponding angles are going to be same. Okay, so now I can say the figures which have the same corresponding angle and the same corresponding ratio are called to be similar figures. Okay, suppose if I take the ratio of corresponding sides, either you can take 2 by 5. Okay, 2 by 5 for the first corresponding side. For the second corresponding side also it is again 2 by 5. For the third corresponding side again it is 2 by 5, and for fourth also 2 by 5. So you can see for all the corresponding sides the ratio is same. Or even you can take larger square by smaller. It means in that case the ratio will be 5 by 2. Again this side 5 by 2. Okay, and the third side 5 by 2, and also the fourth side 5 by 2. Okay, so you can see the ratio remains same. Okay, and what about the angles? Suppose if I name these squares. Okay, so it is A, okay, B, C, D. Okay, and this is P, Q, R, S. Okay, so I can write the corresponding angles. Okay, angle A equal to angle S equal to 90 degree. Okay, because both are squares and we know the property in square each angle is 90 degree. Okay, and similarly if you write angle B equal to angle P is equal to 90 degree. Okay, so in this way you can see that the two figures have the same shape, nothing but they are squares. Okay, and corresponding angles are equal, and the ratio, I mean corresponding sides ratio is same. Okay, such figures are called to be similar figures. Okay, and this you can generalize for polygons. It means how to define two polygons are similar. You can define. Okay, you can define. Okay, so two polygons are similar. Okay, two polygons are similar of same side. Okay, they should have a same side of same side. So when can you say two polygons are similar? Okay, if are similar. Okay, if the corresponding angles the corresponding angles are equal. The corresponding angles are equal. The corresponding angles equal, and the second property is that corresponding sides have the same ratio. Okay, same ratio is also called to be proportion. Okay, so such figures are called to be similar figures. Okay, I hope you understand. Now I'll give some more examples. Okay, now see this one. So this is an application of knowing the similar figures. Okay, so learning about what are similar figures. Okay, learning about what are similar figures. Okay, so knowing about what are similar figures is nothing but your knowledge. It is your knowledge. Okay, and using this knowledge, okay, okay, in real life situations, okay, or real life problems, okay, that is called to be application. That is called to be application. So we need to know why we need to study triangles. Why need to study the properties of triangles? So we have seen in the first slide that the heights, the sides of a mountain are indirectly measured with the help of the principle of similarity of triangles, because we are not going to literally measure the lengths and heights of such big things, isn't it? So the indirect method of measurement is done by with the help of a principle of similarity of triangles. Okay, so one such example. So this is an blueprint of a construction of a building. You can see different shapes are here. You can find some squares, you can find some rectangles. In some blueprint even you can see triangle, circles. Okay, the same blueprint you are going to use in order to construct a building. So this is an application of making use of triangles principle. Okay, done. Next. So this is all about the introduction part of similar triangles. Okay, now if I ask what do you mean by similar triangles? So two triangles are called to be similar if they have a same shape, but size can be same or it is different. But when I ask how to define two polygons are similar, you should say if two polygons are said to be similar if they have a corresponding angles same and the corresponding sides are in the same ratio. With the two conditions you can say the figures, polygons are similar. You can ask me, what if sir, if one condition is satisfied other is not? No, it is not called similar triangles. To say two polygons similar, you need to prove both the conditions. One, corresponding angles, okay, corresponding angles should be equal, okay, and the second, the corresponding sides must have a same ratio, okay, then only the two polygons are called to be similar. Okay, so in the coming video I will give some more examples, okay, and we'll start with the exercise. Okay, and for students who have understood, you can do the activity in home. So this is the activity given in the textbook. So you can see it is a light bulb. Okay, you can fix the light bulb at point O to your ceiling. Okay, and exactly below the light bulb you can you can place a cardboard. Okay, and plain cardboard which is parallel to the table. Okay, and we know the property of light. Light always travels in a straight line, isn't it? Light always travels in a straight line. So the straight line makes the shadow of the cardboard plane. Okay, so you'll get a shadow and the shadow shape is same as the one you are keeping here. Okay, if the cardboard is if the cardboard is in rectangular form, if the cardboard you are keeping is rectangular, okay, rectangle, even the shadow is also rectangle, but there is a difference in the size. It means it is enlarged, the size is enlarged. Okay, so that size is enlarged is also called a scale factor. It is also called a scale factor, I mean if one figure is, okay, if one figure is smaller than the bigger, okay, and I told you if all sides are A for the first square and for the second square all sides are 2A, okay, then what is the scale factor? So scale factor, it will be either 2A by A. If you do, the scale factor is 2 by 1. If you take A by 2A, the scale factor is 1 by 2. Okay, so with the respect to comparison, if I am comparing second figure with the first figure, the scale factor is going to be 2. Okay, if I am comparing first figure with the second, the scale factor is going to be 1 by 2. Okay, so this also you need to know because these are the important keywords. Okay, so such questions, such keywords they can use in framing the question. Okay, fine, do this activity, so you'll come to know what are exactly the similar figures are. Okay, so in this video this much, and in the next video we will start with the exercise and we try to understand even better about the chapter. Okay, thank you.